We know this image well, a solitary, carved facade standing silent in a remote stretch of the southern Jordanian desert. This single tomb is a fragment of a much larger footprint. Beyond the facade, a metropolis once supported tens of thousands of people across the valley floor. Building an urban capital in this specific location defies traditional logic. The surrounding mountains offer natural protection, but they lack the one resource required to support a massive population: abundant water. The Nabataean civilization survived here by looking past the stone. They built an invisible, city-wide infrastructure network that forced the desert to sustain them. In an arid environment, the challenge is twofold. Rain is incredibly scarce for most of the year, but when it does arrive, the precipitation is highly concentrated and volatile. A sudden storm miles away can send thousands of gallons of water rushing downhill. Within hours, a dry, narrow valley becomes a deadly, unstoppable torrent. The inhabitants of Petra could not simply hide from these storms. They had to intercept the runoff and reshape the natural topography into a massive, functioning hydraulic machine. This intervention transformed a geographic choke point into a viable habitat. By controlling the landscape, they created a necessary destination for anyone moving through the region. The first requirement of this urban machine was defense. Before the city could harness the water, it first had to neutralize the destructive force of the floods. This topological map shows how engineers solved the problem. They constructed a massive diversion dam to block the natural flow, forcing the water into a custom-carved 90-meter tunnel through solid rock. The city center remained dry, while thousands of gallons were safely collected. Complex urban engineering starts with observing the landscape's most violent natural threats and designing physical barriers to neutralize them. Once the floodwaters were captured, the focus shifted to storage and transportation. Workers excavated enormous rock-cut cisterns deep below ground level. Storing the water in these dark subterranean chambers shielded the supply from contamination and prevented the surface heat from evaporating their reserves. To bring continuous supply into the city center, they laid miles of gravity-fed pipelines connected to distant mountain springs. These interlocking ceramic sections demonstrate the precision manufacturing required to maintain a consistent gradient over rough terrain. The system was designed with intense geographic overlap. This network map reveals how engineers interconnected multiple distinct springs to feed the central distribution channels. If one spring ran dry, the others continued to provide. This reliance on multiple overlapping sources suggests a deliberate effort to protect the urban supply against localized failures. This intense water management yielded an impressive surplus. Funding an infrastructure project of this scale required immense capital. That wealth came directly from taxing and supplying the merchants moving frankincense and myrrh across the Arabian Peninsula. The city directed this commercial wealth back into its hydraulic systems, creating public pools, terraced desert gardens, and decorative fountains in a region where rainfall was measured in fractions of an inch. The reserves also supported intense biological demand. A single arriving trade caravan could introduce hundreds of exhausted merchants and thirsty camels to the city, instantly spiking consumption. Commercial wealth funded the engineering, and the engineering provided the lush oasis that kept the merchants coming back. Despite this level of sophistication, the urban center eventually emptied. The popular assumption is often a catastrophic earthquake or a violent military conquest. The archaeological record points to a much slower catalyst. The global supply chains and trade networks that funded the city began to realign. This map tracks the shift. As merchants began loading their cargo onto ships to bypass the difficult Arabian desert entirely, the maritime routes gained dominance, and the overland caravan trails lost volume. The physical location of the city remained highly defensible, but as global markets shifted toward the sea, the geographic advantage of controlling a choke point evaporated. Complex infrastructure has a fatal flaw. It constantly consumes human labor to operate. Without the massive tax revenues from the trade routes, the city's population steadily contracted. There were fewer hands to clear sand from the channels, patch cracked clay pipes, and monitor the diversion dams during storms. As maintenance ceased, the water system failed. Silt clogged the cisterns, the protective dams broke down, allowing flash floods to tear through the streets. Cities rarely vanish in spectacular events. They fade. A civilization assesses the changing economics of its environment, stops repairing the machinery, and slowly walks away.